I want you to set aside everything you think you know about trees for a moment. Really, start from zero. Imagine you're holding a seed in your hand. Look at it. It's so light it's almost weightless. A tiny thing, just a few grams, smaller than a penny. Yet we humans believe that this little thing can somehow become a giant creature, dozens of meters tall and weighing 10,000 even 20,000 pounds. You're familiar with the story. We all are. Plant the seed in the ground. Add water. Wait. A sprout emerges, grows bigger, and one day becomes a mighty oak. It looks simple. It looks reasonable. It looks like the tree takes all its material from the very soil it stands on. But pause for a second. Look closely at the paradox hiding beneath what you think is obvious. You have a seed weighing 25 grams, and then you have an oak weighing 20,000 pounds. According to the law of conservation of mass, the fundamental principle Antoine Lavoisier established back in 1789, that mass has to come from somewhere. It can't just appear. No magic. No matter popping out of nothing. So the real question is, where does all that mass come from? Don't answer yet. Think like a physicist. Let your intuition feel a little uncomfortable. Because if your intuition says from the soil, I have bad news for you. That intuition is wrong. Wrong to the point that it misled entire civilizations for thousands of years. We see roots gripping the earth and assume the soil feeds the tree. We see water poured in and think the water turns into wood. We look at the surface and trust what intuition whispers in our ear. But intuition isn't science. If you rely only on intuition, you'll miss the biggest secrets of the universe. Things right in front of you, yet so invisible you've never truly seen them. That's why I want you to stay. Because the answer to the question, where do trees come from, isn't just surprising. It changes the entire way you see the material world around you. And when you see it, when you really understand it, every forest, every tree trunk, even any wooden table in your house will look completely different. Come with me. We're about to unpack one of the greatest misunderstandings humans have ever had about life on Earth. Now let's do what science always demands of us. Eliminate false assumptions, even when they sound incredibly reasonable. And the first assumption almost everyone instinctively believes, is that trees get their mass from the soil. It seems right. Roots dig into the ground, soil clings to roots, the tree stands on soil. But in science, it seems right is often the biggest trap. Let's go back to 1644. When the Flemish scientist Johann Baptist van Helmont conducted one of the simplest yet most intuition-shattering experiments ever recorded. He planted a willow tree weighing 5 pounds in 200 pounds of completely drought soil. Then for 5 years he only watered it. No added soil. No anything else. When he weighed it again, the tree was 169 pounds heavier by 164 pounds of new material. And the soil, he dried it, weighed it, and found it had lost less than 2 ounces, under 60 grams. Pause and do the quick math. The tree gained 164 pounds, the soil lost less than 0.07% of its mass. That means all that material couldn't have come from the soil. No matter how much you trust your intuition, the numbers don't lie. Soil is not the source. It never was. What about water? This is the second assumption almost everyone has believed at least once. The tree absorbs water. Water nourishes the tree, so the tree grows from water. Sounds reasonable. But look at basic physics and chemistry. A mature oak can pull in 100 gallons of water per day in summer, an enormous amount. But water is hydrogen is the lightest element in the universe. Oxygen the tree releases back into the atmosphere during photosynthesis. Most importantly, water contains no carbon, and carbon is the main component of wood. Carbon makes up about 50% of the dry mass of any tree. You can pour as much water as you want into a tree, but water won't turn into carbon. Physics doesn't allow it. So if soil isn't the answer, and water isn't the answer, we've just eliminated the two only sources human intuition always believed could create hundreds of pounds of material. And this is where the question gets more interesting than ever. If the tree doesn't eat soil, doesn't drink water to turn it into wood, then where does all those pounds of material come from? You've seen the seed. You've seen the giant oak, and now you have to face an inescapable paradox. That mass didn't come from anything your eyes saw going into the ground. This can only point in one direction. The origin of the tree isn't beneath your feet. It's somewhere else. A place that surrounds you, touches you every second, yet is completely invisible. Let me tell you the truth. That for thousands of years humans stood right in front of but never truly saw trees are made from air. It sounds almost insulting to intuition, but it's the only thing left when you rule out soil and water with irrefutable numbers. And science, though sometimes brutal to our beliefs, is always loyal to the truth. The air around you contains about 0.04% CO fat odd. A tiny fraction so small even the sharpest eyes might see it as nothing. But don't let the number fool you, because it's precisely those scarce CO fat or molecules that are the raw material from which every forest, every patch of vegetation on this planet is built. Every leaf you see, every trunk you lean against, is living physical proof that the atmosphere, though almost invisible, is actually a colossal reservoir of material. Look at a leaf again. To the naked eye, it's just a thin green fragment. But at the microscopic level it operates like a molecular factory optimized over millions of years of evolution. On the leaf surface are billions of tiny pores called stomata opening and closing constantly to pull CO fat open inside. Once a CO fat or molecule slips through the epidermis, the tree performs one of the most sophisticated operations in biology. It splits CO fat into carbon and oxygen. This isn't simple. CO fat is a stable molecule very hard to break without strong energy. Yet the tree does it millions of times per second using a process entirely driven by sunlight. The oxygen is released outside, returning to the atmosphere, a priceless gift the tree gives back to the world and the very thing you're breathing right now. But the carbon, the heavier, more foundational part, is kept. Carbon is the original raw building block of life. But just keeping carbon isn't enough. The tree uses energy from solar photons to link those carbon atoms together into glucose, the first simple sugar molecule in the building block of life. From glucose the tree makes cellulose, a material that makes up 40 to 50% of wood's dry weight. Then lignin, the substance that makes wood hard, load-bearing, storm-resistant, adding another 20 to 30%. And all of it, every layer, every fiber, every grain of wood you can touch or smell when freshly cut, is carbon. Carbon from the air. Carbon that the leaves pull down from the thin atmosphere enveloping this planet. Let me give you a number you won't forget. A 10,000 pound oak contains about 5,000 pounds of carbon. And every bit of that carbon once floated lightly in the air. You're looking at the sky, but in solid form. You're looking at a column of air packed and crystallized into a trunk. You're looking at wood atmosphere compressed into the shape of a tree. It sounds like magic, but it's not magic. This is physics. This is chemistry. This is the world working exactly as it must. But the truth doesn't stop there. Carbon isn't just what wood is made of. Carbon is the foundational language of all life on Earth. And it's not something easily created. Under normal conditions, carbon isn't produced on the planet. It doesn't come from soil, from rocks, from the ocean. Carbon is forged in the most terrifying natural furnaces in the universe. Stellar cores. Billions of years ago, when the universe was young and full of giant stars, inside their cores the triple alpha process occurred. A reaction where three helium nuclei smash together with tremendous energy to create the first carbon atoms. If conditions in a star's core changed even slightly, carbon couldn't form, and carbon-based life as we know it would never exist. When those stars died in supernova explosions, they scattered carbon into space, sowing seeds for future planets. Some of that carbon condensed into Earth, and billions of years later, that carbon combined with sunlight to become trees. Meaning when you look at a tree trunk, you're looking at remnants of ancient stars, reborn in an entirely new form. You're looking at matter that once stood in a stellar core hotter than 100 million degrees, now standing still under sunlight, silent, green, gentle. A tree is a physical reminder that nothing in the universe is truly lost. It only changes form, and for all those reasons, that's why I say trees are still air. Wood is solidified sunlight. What was invisible becomes visible. What was light as air becomes something you can hold, sit on, climb, or build an entire house with. But let me take it one step further. If trees are made from air, and we can no longer deny that, then what does that say about you, about your body, about every cell, every tissue, every gram of flesh on your bones? Do you think you're made from soil, from water, or from food? Yes, all those things play a role, but the real material that makes up you, the heaviest, most important part, also comes from the exact same place trees get the material, air. The carbon in your body was once CO2 drifting in the sky, pulled down by trees, turned into sugar, turned into tissue, turned into tissue, turned into food, then turned into you. So the story isn't just trees are made from air. The story is you are too. But hold that thought for just a moment. And to understand how a tree can take a stable molecule like CO2 and break it into solid carbon, we have to look at something even more fundamental than air. Every life process in a tree begins with particles of light, photons emitted from the surface of the sun, traveling 150 million kilometers across space in 8 minutes and 20 seconds to strike the surface of Earth. Pause and think for a moment. These photons left a gigantic thermonuclear reactor where temperatures exceed 15 million degrees Celsius. And after an unimaginable journey, that ancient energy is now lying on the leaves right outside your house. And the strangest thing is that the leaf knows exactly what to do with it. When a photon hits the leaf's surface, it encounters chlorophyll molecules, molecular antennas, evolved to absorb light perfectly. The photon transfers its energy to an electron in the chlorophyll, kicking the electron up to a higher energy level. That's the first spark, the initial push that all life on Earth depends on. This excited electron is passed along a chain of molecules, releasing energy step by step, and the tree converts that energy into chemical form, ATP and NADPH, the energy currencies that cells can use to do work. Everything I just described happens millions of times per second, in every leaf you see. But the most important thing isn't the quantity or the speed. The most important thing is the extraordinary ability that light gives the tree, the ability to break CO2 apart. Normally, CO5 is one of the most stable molecules in we've ready. If you want to separate the carbon from the oxygen, you need temperatures high enough to melt metal. But the tree does it at room temperature, in a gentle breeze, under warm sunlight, and using only light. This isn't just strange, it's a profound piece of the universe's physical code. Light, a pure form of energy, becomes the power to shape matter. Thanks to photons exciting electrons, the tree has enough energy to force CO4 molecules to split, and then recombine the carbon with a nut into new structures. The carbon-carbon bonds the tree creates are the very bonds that hold wood upright. That's the bond you feel when you lean against a trunk. That's the bond you smell when you cut fresh wood. That's the bond fire has to break when you burn a log. And this is what I want you to really feel. The energy of sunlight that you can't touch, can't hold, can't see in material form, has been turned by the tree into solid chemical bonds. When you hold a piece of wood, you're holding sunlight frozen into an atomic structure. Every carbon-carbon bond in that wood is a photon that has been transformed. A photon that came from the heart of the sun. A photon that left our star just minutes ago to become matter in your hand. If you think this sounds too poetic, remember this isn't a metaphor, this is physics. Electromagnetism is the force that governs every chemical bond in your body, and in every cell of the tree. It's the electromagnetic force that keeps electrons around nuclei, keeps atoms bonded together, keeps molecules structured and stable. So light, a manifestation of the electromagnetic force, doesn't just shine down on Earth, it's shaping Earth. It's the invisible builder constantly rearranging carbon atoms to create wood, leaves, flowers, fruit, and the entire living world you know. You've never touched light, right? But when you place your hand on a tree trunk, you're touching light that has been turned into matter. You're feeling electromagnetic in solid form. And when you understand that, a tree isn't just solidified atmosphere. It's also light written into structure. A material record of photon-electron interaction stretched across millions of years of evolution. That's why I say the tree outside your window isn't just a living thing. It's a physical equation carved into three-dimensional space. If a tree can turn air and light into solid matter, then ask yourself what happens when you eat an apple or a slice of bread or a piece of meat. You think you're eating food, but physically, you're putting into your body matter that was once frozen light and rearranged atmosphere, and that leads us to a truth, sometimes overlooked. Because it's so obvious your body is also made of carbon, and that carbon, just like the tree's carbon, comes from CO2 in the air. About 18% of your body weight is carbon. If you weigh 150 pounds, then around 27 pounds of you is pure carbon, and that carbon didn't come from soil, didn't come from water, and didn't come from air directly. You can't breathe in CO2 and turn it into muscle, but trees can. And trees have done it for you. When you eat plants, you're eating carbon that trees pull down from the atmosphere and packaged into glucose, cellulose, starch, fats, proteins. When you eat animals, you're eating carbon from plants, again, just through an intermediate step. The food chain is really just a chain of carbon transfer from air and into plants, into animals, into you. This isn't philosophical metaphor. This is the physical equation of life. Your body is tree carboned in a more intricate order, but let's go even deeper. There's an interesting detail many people don't know. When you lose weight, most of the weight you lose doesn't go anywhere. It doesn't turn into energy, doesn't leave as sweat or waste. It goes back into the air. The carbon in your fat is broken down by your body into CO2, and you breathe it out. That means, when you lose 10 pounds, about 8.4 pounds of it leaves your body through your breath, returning to the atmosphere, ready to be absorbed by another tree. Every time you exhale, you're returning carbon to the world. Every time you inhale, you are taking in O2 that trees gave back after removing the carbon. It's a beautiful closed loop, and you're literally part of it. But this loop doesn't just happen over a few years, or a few generations. It happens over millions, even billions of years. The carbon atoms that make up your heart, your brain, your hands, have been in the bodies of other creatures before. Maybe in a dinosaur that walked the earth 100 million years ago. Maybe in ancient fish in the primordial ocean. Maybe in the leaf of a tree that fossilized into coal. Maybe in a molecular cloud, before Earth even existed. Your carbon has been in rocks, in water, pitch and water and organisms, in the atmosphere. And if you stretch the story far enough, you'll see the most magnificent thing. The carbon in your body was once in the core of a star billions of years ago. You aren't just made from trees. You are made from stars. When you grasp this, you see that your body, what you still think of as you, is really just a temporary arrangement of ancient atoms. Atoms that have wandered the universe for 13.8 billion years and paused temporarily in human form. You don't own your atoms, only borrow them, for a short time. When you die, they will continue their journey, returning to the soil, dissolving into body, rising to the atmosphere by trees again, then entering another creature. Matter has no beginning or ending history, only changing forms, and you are one of those forms. A form capable of wondering about its own origin. A form star carbon temporarily self-organizing into consciousness, experience, thought. Meaning you aren't just connected to trees. You are their kin, trees. And you both are solidified atmosphere, shaped light, and star matter pausing temporarily in living bodies. And when you accept that truth, you'll see that the line between tree and person isn't as clear as you once thought. Both are products of the same universe, written with the same alphabet of matter, and that leads us to an even bigger question. A question that touches the very essence of life. If your body is made of matter that existed billions of years ago, then what is life really? What makes a collection of atoms capable of thinking about itself, and what keeps that order existing in a universe always tending toward chaos? To understand more deeply the journey that the carbon atoms in your body have traveled, we must look at a cycle that encompasses not just Earth but the entire universe, the cosmic carbon cycle. The carbon you carry in your bones, in your blood, in your DNA is not new in any sense. No carbon atom has ever been created on Earth throughout this planet's 4.5 billion years of history. All of it comes from ancient thermonuclear reactors, in the cores of massive stars, where helium is compressed until 3 nuclei collide in the triple alpha process to produce carbon. And when those stars die in supernova explosions, blasts so powerful they can light up an entire galaxy, they scatter carbon into space like seeds for future life. Some of that carbon drifts through space for millions of years, condensing into the primordial dust clouds that form the solar system, merging into Earth, then joining the atmosphere, oceans and minerals. From the atmosphere, carbon is absorbed by trees. From trees, carbon enters animals. From animals, carbon enters you. Then you exhale it as CO2, and it returns to the air, to be absorbed by trees again. A complete loop with no beginning and no end. Carbon simply changes residence. This leads to an important realization. No atom in your body is yours, in any permanent sense. No new atoms are created when you are born and none disappear when you die. Only the form changes. Only the organization changes. And it is precisely that organization, the temporary arrangement those atoms take, that we call you. That is why I once said life is the way the universe observes itself. The universe did not create carbon to make trees or humans. The universe simply created carbon because the laws of physics allowed it. But carbon, with its ability to form 4 bonds, with its unparalleled flexibility in the periodic table, became the foundation for life. And life quite literally is star atoms reorganized into something capable of looking back at the universe and questioning its own origin. But to grasp the extraordinariness of life, you need to view it through the lens of entropy. According to the second law of thermodynamics, every isolated system tends toward greater disorder over time. The universe wants to decay. It wants to spread energy, to dissolve into thermal chaos. Yet life does the opposite. Life creates local order amid global disorder. It gathers atoms into molecules, molecules into cells, cells into tissues, tissues into organisms. Life is a temporary pause in entropy, a stubbornness against the natural flow of the universe. But it can only exist because energy from outside, from sunlight, continuously pours into the system, creating small pockets of order in a sea of chaos. Without the sun, all carbon-based living structures would collapse back into inorganic, and that is why life is so fragile. Carbon-based life is not inevitable. It exists only because of a delicate chain of balances. Earth's distance from the sun, carbon's unique chemical properties, a stable atmosphere, liquid water, and 3.8 billion years, uninterrupted by absolute catastrophe. Change any part of that chain, and there are no trees, no animals, no you. But it is precisely because of that fragility that life becomes miraculous. It is not durable. It is a delicate vortex that resists entropy while compromising with it, existing while dissolving. Look around you. Every living thing on Earth, from the tiniest ant to the giant sequoia towering 300 feet, operates with the same chemical language. DNA, RNA, proteins, lipids, all built on carbon, all using the same molecular alphabet, as if the universe chose carbon as the foundation for life from the very beginning. And this is what makes the understanding profound. You human are not an exception, not a creature standing outside nature. You are an extension of the carbon cycle, its most complex pattern, proof that star matter, when organized just right, can become self-aware of its own existence. Once you see this, you can never look at your body, at trees, or at any living thing the same way again. You will see life as a symphony of energy and matter, of light and carbon, of local order defying entropy. And when you understand that, you are ready to look at the universe with an entirely new pair of eyes. Eyes that see the connection between all living beings and the long-dead stars. And now, after tracing the journey of carbon, of light, of trees, of yourself, we can return to the starting point, the seemingly simplest question of all. Where do trees really come from? And you can see it so clearly, it's almost amusing. No, trees do not grow from the soil. Our intuition for thousands of years has deceived us subtly but completely. Soil supports the tree, holds the roots, provides minerals, but it does not create the trunk, does not create the leaves, does not create a single ounce of the tons of carbon in them. Trees come from air. Trees are CO2 turned into solid matter. Trees are light packaged into chemical bonds. And above all, trees are products of time. Years, decades, centuries of light and air gathered into the form of a still being standing before you. If you had to sum up the physical essence of a tree in a single equation, it would be tree equals CO false plus light plus time. It sounds simple, but behind it is the entire universe operating in a way that only thinking beings can see. And this leads us to a far broader conclusion. Every living thing on Earth, every bird, every beast, every tree, every creature in the sea, is an expression of the universe's deepest physical laws. None of us is separate from the universe. We are the way the universe experiments with countless configurations of carbon, hydrogen, oxygen, and light. This sounds like philosophy, but it is not philosophy. It is physics seen through the lens of life. Try to picture it with me. You stand before a vast forest, sunlight filtering through the canopy, a gentle wind swaying trees dozens of meters tall. You are not just looking at trees. You are looking at a new chapter in the universe's 13.8 billion year story, from the first supernova explosion, to the formation of carbon, to carbon falling to Earth, then being drawn into CO4, absorbed by trees, and finally becoming the forest. A forest is the history of the universe written in matter, and you standing in that forest are also a chapter in that same story. Understanding this does not make the world lose its beauty, it makes the beauty deeper. When you understand why something exists, you no longer just see its form, you see its origin, its journey, the subtlety behind its existence. A tree is no longer just a tree, it is star matter reorganized into life. It is ancient sunlight trapped in carbon chains. It is still air. It is proof that the universe, through simple yet powerful laws, can create something solid, beautiful and full of knowledge like wood. And if a tree, through physics, can become the backbone of a forest, then humans, through the very same star atoms, can become the backbone of knowledge. You are the matter of the universe, but matter that knows how to ask questions. You are an assembly of atoms capable of looking at a tree and asking why. And in that very moment, you prove that life is not just chemistry, it is meaning. Physics does not give you answers about purpose, but it gives you a mirror to see your place in a larger, older, more beautiful picture. And that is what makes science a spiritual journey, no less profound than any philosophy humans have ever created. So when you step outside, when you look at a leaf or a trunk, I want you to know that you are seeing light and air in living form. You are seeing the story of ancient stars. And I want to invite you to keep going with me, to keep looking at the world through the eyes of science. A world no less wondrous, but real, profound and beautiful, in a way you can never go back to the old way of seeing. Because when you understand trees, you understand carbon. When you understand carbon, you understand stars. And when you understand stars, you begin to understand. If you want to continue seeing the world the way science truly reveals it, please subscribe so you don't miss the next journeys. See you in the next exploration, where the universe once again leaves us in awe.